Okay, so let's dive right in. What if I told you that one single day on the calendar, just one day, holds the key to understanding how planets move, how your GPS works, and maybe even why the price of that plane ticket you were looking at just changed?
That day is March 31st. And I know what you're thinking, March 31st. But yeah, it's arguably one of the most golden dates in the entire history of mathematics. And over the next few minutes, you're going to see exactly why.
See, on this one date, we're talking different centuries, totally different places. These incredible minds, all connected to this day, completely changed the world we live in. So let's meet them.
First up, a huge question. I mean, think about it. Why don't satellites and planets just fall out of the sky, right? We launch these massive rockets, we've got all this stuff orbiting the Earth, planets have been doing their thing for billions of years, so why don't they just, stop or fall down? What's the invisible force, the hidden language that keeps the whole cosmic dance going?
Well, to get our first clue, we have to go back to March 31st, 1727. This was the day the world lost an absolute giant, Isaac Newton. See, Newton was wrestling with gravity and motion, and he realized the math they had back then just wasn't cutting it. So what do? Well, if you're Newton, you invent a whole new kind of math. He called it calculus. It's literally the language of how things change. And for the very first time, we had the tools to describe and even predict how anything moves. We're talking everything from a simple apple falling from a tree all the way up to a planet's orbit.
It's like the universe was running on this hidden code, the secret language of motion. And Newton, he's the one who gave us the key.
So we've got our first piece of the puzzle. Now, stick with me here. Same date, March 31st, but let's jump back in time now, way back, more than 100 years before Newton was even born. All right, next mystery, and this one's sitting right in your pocket. How does a video game or your GPS know exactly where you are on a map? I mean, really think about it. How does a computer know the precise location of any single point on a screen?
You guessed it, the answer starts on March 31st. This time, 1596, the day a man named René Descartes was born.
Descartes had this idea, and it was so revolutionary because it was so simple. He just imagined two lines crossing each other. An x-axis going side to side and a y-axis going up and down. And with that simple grid, bam, any point anywhere on a flat surface could be described with just two numbers, an x and a y. This was huge. For the first time ever, it connected the world of numbers, algebra, with the world of shapes, geometry.
I mean, stop and think about that for a second. Every single point in our digital world, every pixel on the screen you're looking at right now, it all lives on a map that he first dreamed up over 400 years ago.
Okay, you see where this is going. One date, so many incredible stories. We've got the math of motion, and now the math of location. So let's keep going. Where to next? All right, here's one you've definitely felt. Why do the prices for flights or things you're shopping for online seem to change almost randomly? You look up a flight, you come back an hour later, and the price is totally different. It feels like chaos, right? But it's not. It's math. And for this piece of the puzzle, we have to thank a man named Augustin Cournot, who died on, you guessed it, March 31st, 1877. So, Cournot was a total game changer. He was one of the first people to look at the messy world of economics, supply and demand, all that stuff, and think, hey, I bet we can use math to explain this. He created formulas to actually predict how prices change based on how much of something there is and how many people want it. This was the foundation for the math that companies like Amazon and the airlines use every single day. So, the price you pay online, it's not random at all. It's being calculated with the kind of math that he invented. All right, look at our timeline now. It's starting to fill up. We've got Newton, Descartes, Cournot, but we've got one more story to tell. So let's make one last jump, this time much, much closer to home. Final question. What do a honeycomb, a snowflake, and a beautiful mosaic all have in common? I mean, they look different, but they're connected, right? The answer is pattern, a deep mathematical beauty. And that brings us to our last genius, a man who was obsessed with these patterns, Donald Coxeter. People called him the modern king of geometry, and he passed away on March 31st, 2003.
Coxeter spent his entire life just exploring the pure mathematics of symmetry and complex shapes. He was fascinated by them. And his work on patterns and how things fit together, well, it influences everything from art and design to virology and modern computer graphics.
He really showed us something profound, that the universe doesn't just use math to work,
It uses math to be beautiful.
So, here we are. Let's recap. We have Newton, Descartes, Cournot, and Coxeter. 4 brilliant minds from totally different eras, working in totally different fields. But they all shared this one single day, March 31st. So what's the real connection here? What ties them all together?
It's actually pretty simple and kind of beautiful. They all searched for the patterns hidden in the chaos. Each one of them looked at some messy, complicated piece of the world and thought, you know what? There's an order here. There's a pattern, and I can find it.
And that really leaves us with one last question to chew on, doesn't it?